So once again, no matter what method of is your choice of solving, your solution should be the same. Let's begin by substitution. Let me go. Yeah, substitution. Can everyone see this in the back? Sort of. Okay. So let's think back to our steps from Monday. The first step is to pick what variable you're going to solve for, and you don't want to pick any variable. You want to be strategic about it. All right. Math is also about efficiency. You're looking for the easy variable. Which one can you solve for that is going to require the less amount of work, the less amount of time? If you look at the first equation, you could solve for x by simply moving 4y to the right, or you could do the same for the bottom. Move the x or move the y. It really doesn't matter. I'm going to go ahead and I'm going to go with what I think most people did, which is they solved the second equation for y. So let's say that we did that. That is going to be the following. It's going to be x plus y equals 2. So if we're solving for y, then we're going to move the x to the other side, and that's going to give us y equals 2 minus x or negative x plus 2. I'm going to leave it as 2 minus x just because that's what I saw some people do. So just going to double check, or I'm going to check in with those people that did that. All right, so we have y equals 2 minus x, and that is one equation that is already solved for. So I'm going to go ahead and just highlight this so that we know what we're working with. All right, substitution requires you to substitute. It's in the name. You're going to substitute whatever y is equal to with 2 minus x. So we're going to go to the first equation now, which is x minus 4y. But instead of y, I'm going to write 2 minus x. So that way I have this. X minus 4, 2 minus x, and all of this is going to be equal to 12. So keep in mind, all I did is I just took this and I replaced it here. Right? Because that is what originally was equal to y. You're replacing. That is all you're doing. Okay. This is some basic algebraic work right here. You guys should all know how to use the distributive property. Distributive property is just multiplying across. You're not multiplying 4, you're multiplying negative 4. All right? That seems to mess people up. Don't forget there's a negative in front. So, negative 4 times 2, negative 4 times negative x. We're going to get the following. We're going to get x minus 8 plus 4x equals 12. Once again, x minus 8 plus 4x equals 12. How do I clean this up? Combine like terms. And what are the like terms that I can combine here? 4x and x. 4, have 4 x's, and I add another x, I get 5 x's total. This is going to equal 5x minus 8 equals 12. And then what? Two-step equation. We're all experts at two-step equations. First step is to do what, Design? Add 8. 5x equals 20. And then final step will be divide by 5. And we find that x is equal to 4. Okay. I'm going to move this out of the way real quick. Oops. Erase this. Okay. Now, there are two variables to solve for, not just one. So yes, we solved for one of them. Now we have to go back and solve for the other. So I'm going to use this equation, y equals 2 minus x. And instead of x, I'm going to write a 4. So now we're going to take this, and we're going to do the following. We're going to do y equals 2 minus, instead of x, you're going to write 4, since that's what we solved for. Okay? And that should be super simple. 2 minus 4. What is 2 minus 4? Negative 2. And so that gives you a solution of the following. By the way, simply writing your answer, x equals this, y equals that, that's not a complete statement. A full solution is a coordinate point. We're looking for coordinate points. So what I want to see in your solution, in your answer, is the following. I want to see this. Solution. Four comma negative 2. This is what I want to see as your guys' final answer. I want to see that statement. Solution and then the coordinates. You're putting the x followed by the y. Okay. Any questions with solving by substitution before we move on? Please feel free to ask questions. Don't be shy, you guys. This is your learning. Okay. So any steps that you didn't understand, please let me know. All right. In that case, let's move on and solve by graphing. So now we're going to be graphing. So if we're graphing, obviously you need a graph, so draw one. Let me use black. Okay. And let me get the ruler. If you don't already have a straight edge, please consider getting one. I don't think I have rulers for everybody. Or for anyone, I don't. For that matter. Alright. Alright. Then we have okay. Alright, sorry about that. It's easier to do on Notability. Okay, so if we're solving by graphing, you still have to solve this to get it in terms of y equals. You need these in slope-intercept form. So slope-intercept form for the first equation, this one here, should be pretty easy. You just move the x, so this becomes y equals negative x plus 2 or 2 minus x. The same thing we had over here. Hi. Thank you. So this is one of the equations. And then this other one is going to be more work. So maybe I should do this one. I'll do it kind of down here. X minus 4y equals 12. I'll do it down here. X minus 4y equals 12. How do we solve for y? We begin by moving the x. Negative 4y equals negative x plus 12. And then we divide by -4 on both sides. -4. Keep in mind, you are dividing everything by -4. And once you do that, this will become y equals 1 over 4 x minus 3. Once again, 1/4 x minus 3. So this is the equation that we're looking to get from what was originally x minus 4y equals 12. By the way, looking at this equation, 1/4 x minus 3, what is the slope going to be for this question right here? Or sorry, for this equation? What is the rise going to be? 1, and the run is 4. So that means you're going up 1 unit, 4 over. And we're starting at -3. So why don't we begin with that one? I'll do it in green so you guys know which one I'm looking at. That one was 1/4 x minus 3, so that starts at -3. And we're going up 4 and over 1. Sorry, no. Up 1 and over 4. Up 1 and over 4. Up 1 and over 4. Not sure yet where they will cross. Looks like they will cross. I think those 3 points is good enough. So, can I use this ruler thing here? Okay. And we're going to go ahead and graph a straight line right here. So that's the first one. Now we're going to graph -x plus 2, which means we're starting at 2. And if I have a slope of -x, what does that mean? -x, because I don't see a number in -x. So what do you guys think that means? It's a -1. So what is the rise? If it's a -1, what's the rise? Up 1 or down 1? Down 1 and then left 1 or right 1? Right. I was going to the right. So down 1 over 1. Down 1 over 1. All right. Slope point here, point here, point here, point here, and point here. All right. Okay. Looking at this graph and your graph, let's find that point of intersection. Remember, that will be our solution. The point of intersection is the point, what? X comes first, so let's count. We go 1, 2, 3, 4 to the right, so that's 4. And then y, 1, 2, 2 down, -2. So we find that the solution is the same. It always has to be the same. Okay, no matter, like I said in the beginning, no matter what method you use, whether it's substitution, elimination, graphing, if you have the system, the same system throughout all those methods, all the time, the solutions will be the same. Are there any questions when it comes to graphing before we move on? Because we are going to talk about 3 variable systems. All right. Any questions? Okay. I'm going to clean up the notes real quick, so let me stop recording. Record this so you guys can watch this later. There it is. All right. Yes, sir. I'll write your name right now. So, you're going to title this 3 variable systems, and then I want you to write that example down that you see on the board. 5x minus 2y plus z equals 11. 2x plus y plus 3z equals 0, and 6x minus 2y minus 2z equals 16. All right, 3 variable systems are made up of 3 variables and 3 equations. Okay. You'll also notice that next to each variable, I have labeled it with a letter. Please label it as well. First equation, label that A. We'll refer to that equation as equation A. Second equation, label that equation B. And your third equation, you're going to label that equation C. All right, A, B, and C. And I want you guys to give me a thumbs up when you have all 3 equations written out. Okay. Please write your first step. Here is your first step. Step 1. Create 2 pairs of equations. Once again, step 1 is to create 2 pairs of equations. Please keep your notes organized as well. So if you're able to make it look nice, try to make it look nice. All right. So what does it mean when we create 2 pairs of equations? So I told you guys earlier that the whole goal of being able to solve a 3 variable system, or not the goal, but the way in which we're going to do it is through elimination. And we have to make pairs of the equations so that we're only dealing with 2 equations at a time, because 3 equations is too many. So labeling them A, B, and C allows me to do the following. I'm going to pair up A and B, and then I'm going to pair up B and C. You could do A and B and A and C, but for the notes, I'm just going to do A and B, B and C. So this is how I'm going to do it, okay? A and B. A and B will be following. 5x minus 2y plus c equals 11. And 2x plus y plus 3z equals 0. Okay. That is your first pair, A and B. Once you have this written out, you're going to write your second pair, B and C. B and C. And that'll be 2x plus y plus 3z equals 0. And 6x minus 2y minus 2z equals 16, like that. Okay. So basically you have these 2, A and B, B and C. These are your 2 pairs. Got it? Right, your second step, step 2. In each pair, choose a variable to eliminate from both groups. It has to be the same variable. For example, if you choose to eliminate x in the first equation, then you must eliminate x in the second equation as well. It applies to any variable that you choose to eliminate. Must be the same variable. There is also some method to the madness. Choose a variable where you don't have to find a crazy like lowest common multiple. So typically there will always be a variable that is just a singleton, like just a y or just a z. If you have a coefficient in both equations for that same variable, then you have to find a common multiple, and it's a lot of work. So I'm going to give you two options right now. In pair A and B, we can solve for y or we can solve for z. I am not going to let you guys solve for x yet, because like I said, with x you have 5x and you have 2x, and then you have to find a multiple of 5 and 2, and it's extra work that I don't want to add on top of this. So pick which variable you want to solve for. You guys want to solve for y, or do you want to solve for z? Raise your hand if you want to solve for y. Raise your hand if you want to solve for z. Okay. Not that many people raise their hands, but I think more people will raise their hands for z. So let's try that. Okay. With elimination, you want the following. You want to have the same number of z's, and you want one of them to be positive and one of them to be negative. So we currently have 3 down here. If I want to cancel this 3, how many z's do I need up here? I need 3. If this is positive, then this must be negative. So I'm going to multiply the top by negative 3, because I want to get negative 3z. We're not substituting. This is elimination. Yes, this is all elimination. The bottom does not get multiplied. Okay? You don't have to multiply the bottom by something. You can leave it as it is. So we're going to multiply the top by negative 3. This negative 3, I need to distribute to every single term. To the 5, to the 2, to the 1, to the 11. So I'm going to rewrite this down here. Negative 3 and 5 makes what? Negative 15x. Negative 3 and negative 2 makes positive what? 6y. Negative 3 and z makes negative 3z. And negative 3 and 11 makes negative 33. Okay. So all I did was multiply that first equation by a factor of negative 3. Are we good so far? I'm going to wait for you guys to finish writing so I can move on. Underneath this equation, we have equation B, which is 2x plus y plus 3z equals 0. And what we're going to do is now we're going to combine these together. Okay. We're going to go ahead and combine these together. Start with the x's. Negative 15x plus 2x. What do you get? Negative 13 or minus 13x. 6y plus 1y. 7y. The goal was to cancel the z's, and we did that. So cross those out. And we're going to get equal to negative 33. By the way, you guys don't have calculators yet, so send one person to get calculators, because we're going to use them for later. One person from each group, please get a calculator. No, está bien. All right, we have our calculators. Okay, please box this right here. We're done for right now. All we want to do is we want to get rid of one variable so that we can make a system of two variables. We want to reduce the number of variables little by little until we are able to solve for a variable. So far we have this. Now, keep in mind, we eliminated variable z. So in the equations b and c, in that second pair, we're going to try to eliminate z again. So let's take a look. All right. 2x plus y plus 3z equals 0. 6x minus 2y minus 2z equals 16. So now we're looking to get rid of the z's. But I have a 3 and I have a negative 2. Not ideal, but we can work with it. We have to find a multiple of 3 and 2. Multiple. Bigger. In this case, the multiple would have to be 6. So, how do I get 3 to become 6? I multiply by what? By 2. How do I get 2 to become 6? Multiply it by, not negative, because it's already negative. I don't want them both to be negative. In this case, just positive 3. Okay. In red, I'm going to write the first equation. So 2 times 2 is 4. I get 4x. 2 and y makes 2y. 2 and 3 makes 6z. And we get 0. 3 and 6 makes 18. 3 and 2 makes negative 6y. 3 and 2 makes negative 6z. 3 and 16. What is that? 48? 48. Okay, go ahead and write that down. You guys ready to combine like terms? Okay. 18 plus 4. 22. Negative 6 plus 2. Negative 4. Z's are going to cancel out. We're going to get our second equation, 22x minus 4y equals 48. So everything we just did, guess what we have to do? We're going to do it again. But this time, we have a new system of equations that only contains two variables, x and y. Okay? So I'm going to do the following. Ready? We're going to make a new system. Make a new system. And this new system will be composed of negative 13x plus 7y equals negative 33 and 22x minus 4y equals 48. This will be your new system. Go ahead and write that down, please. Okay, you know okay so far? All right. We're going to use elimination again. And this time, look at the numbers that we are given. These numbers are not pretty, so you got to pick wisely. Should we eliminate the x's or should we eliminate the y's? What would be easier to find? A multiple of 13 and 22 or a multiple of 7 and 4? 7 and 4. What is the least common multiple of 7 and 4? 28. 28. So, how do I get 7 to become 28? Multiply it by 4. How do I get 4 to become 28? Multiply by 7. Notice, negative 4. So I'm not going to multiply by a negative. I need one of these to stay negative. So both of these will get multiplied by positive factors, positive numbers. Okay. We're almost finished. 4 and negative 13 makes negative 52. 4 and 7 makes 28. 4 and 33. Use a calculator. Don't know what that makes. When you have the answer for 33 times 4, raise your hand so I can get it. 132. Good. Negative 132. Okay. Let's do the bottom. 22 times 7. Use a calculator. I don't know what that is. When you have it, let me know. 154. You sure about that? 154? Yes? Okay. 154x minus 28y equals, what's 48 times 7? 336? 336. Okay. Now we combine like terms. (52) and 154. Negative 52 and 154. What is that going to make? 102. The y's will cancel. So 102 equals what? 204? 204? So that means that x is equal to 2. All right. We got one variable. We got to get 2 more, but at least we got 1. But I promise you this is going to be easy. Once you have one of them, it's just working your way back up. So, so let me show you what that looks like. I'm not sure. I haven't seen it. It's already made. Yes. Okay. Since I have you all warmed up, let's not get cold. So I have x equals 2. I'm gonna pick one of these 2 up here to substitute x into. Let me go with negative 13 because I feel like those numbers are smaller. Negative 13 times 2 plus 7y equals negative 33. I replace the x with a 2. Now that I know that x is equal to 2, replace the x. Negative 26 plus 7y equals negative 33. This won't. It'll be next week's quiz. Yeah. All right. We add 26 to both sides, and we get that 7y equals negative 7, so y equals negative 1. Okay. So now we have 2 variables. We just need to solve for z. And we're doing this faster than it took me with first period. So you can tell them. And I have it on tape too. That fifth period is better than first period. We're going to take one of the equations from the very beginning, either equation A, B, or C, and we're going to put x and y into that equation to get our final answer of z. I'm going to use equation A, which is 5x minus 2y plus z equals 11. And I'm going to replace my x. I'm going to replace my y. It's going to be 5 times 2 minus 2 times negative 1 plus z is equal to 11. Did I lose anyone yet? Good. Sort of? Okay. 5 times 2 is 10. 2 and 1 makes 2. Almost there, guys. Twelve plus z makes 11. Almost there. One step. One more step. Subtract 12. Z is going to equal negative 1. Hold on, we're not done. What do I want to see as your answer? Remember, solution. I want to see it as an ordered triplet, x, y, and z. So your solution will be 2, negative 1, negative 1. That is what I want to see on next week's quiz. This will not be on your quiz Friday. This will be on it next week. All right. Any questions before we take our break? All right, let's take our break. 10 minutes.